we need to look into the control of respiration, specifically the control of lung perfusion to start with. Now, we already discussed perfusion, the idea of that blood flow coming around the alveoli, making sure that pairs evenly with ventilation, the air coming in. But lung perfusion, if you have lower local partial pressure of oxygen, so in that area is just not enough oxygen, basically what's going to happen is the capillaries are going to divert blood. They're kind of strict. And they'll divert blood to areas that have higher partial pressures of oxygen. So it'll direct the lobules with the high partial pressure of oxygen. That makes sense if you think about it, because why would you want to put more blood to areas that have low oxygen content? Instead, you divert it to areas that have higher, making sure that blood flow matches where the oxygen is present. Now, alveolar ventilation, we've mentioned this one before. Ventilation is the airflow coming in. But we're going to look at now high partial pressure of CO2 in the blood. So for example, if you have high partial pressure of carbon dioxide in the blood, that can stimulate bronchodilation in certain areas. Because if you dilate the bronchioles, that means more airflow in and out. So if you have high blood carbon dioxide, more air going out means more carbon dioxide can leave with it. So again, it's helping to make sure that you're getting rid of high levels of carbon dioxide, and it matches ventilation and perfusion. So we're not just always focusing on oxygen, we can focus on carbon dioxide levels as well. So we'll continue on with this control aspect. Those are both local small controls. But we also have the nervous system control. The main areas from our nervous system coming down control-wise are medulla and the pons. So we need to start with going through the medulla aspect first, and we'll get to the pons a bit later. We have two different main groups to look at. We have the DRG, or the dorsal respiratory group. Now, like the name implies, it's towards the back, dorsal respiratory group. This dorsal respiratory group is going to innervate the diaphragm and your external intercostals. Think diaphragm is that dome-shaped muscle that contracts. The external intercostals are going to help with increasing your rib volume. Now, they're going to integrate with stretch receptors and chemoreceptors. So looking at stretch receptors, because your lungs can only get so big, but chemoreceptors to monitor the different chemicals, oxygen, carbon dioxide, know what is where, as well as several other inputs. So this is your dorsal respiratory group. The other one is the ventral respiratory group, the VRG, or the ventral respiratory group. Now this one is going to be more of a rhythm generating. It sets eupnea. Eupnea basically is your breathing rate. It's about 12 to 15 breaths per minute on average. Now, can some people have more, some people have less? Sure, that's possible. But if you go across the entire population, you're looking at about 12 to 15 breaths per minute. So that's the ventral respiratory group. But now, during forced respiration, forced is you're breathing in or out quickly. It's not your normal breathing. During forced ventilation, the inspiratory neurons are exciting the inspiratory muscles. Makes sense. So inspiratory neurons, breathe in, excite the inspiratory muscles, breathing in. Now though, the expiratory neurons, they don't excite the expiratory muscles. Instead, those expiratory neurons inhibit the inspiratory neurons. They basically tell those inspiratory ones, say, don't fire, stop firing. Don't cause the inspiratory muscles to be stimulated. Don't cause them to contract. So this is the VRG, and that's during forced inhalation, exhalation. Eupnea is just standard breathing, that's resting state. So it has two different states here. Your resting state breathing or your deep forced breathing. So let's look at quiet respiration. What happens? First of all, in quiet respiration, the DRG, dorsal respiratory group, is activated. That's going to start everything off. It causes your muscles to contract. Primarily your diaphragm is contracting. That causes inspiration to occur. Then after that, the DRG is inhibited. Base says, don't send a signal, stop. Don't cause inspiration. By doing that, it allows those inspiratory muscles, the diaphragm primarily, to relax, go back to its dome shape. By going back to its dome shape, it allows passive expiration. So by allowing the muscle naturally to recoil to its resting state, you've decreased the lung volume, which increased the pressure, and air flowed out passively. That's quiet, standard, just basic respiration. But now in forced respiration, that's when you're breathing deeper in and out. We're going to have the DRG and the inspiratory VRG both being activated. So you're now using both systems, the dorsal and the ventral respiratory groups. But you're focusing on the ventral respiratory group's inspiratory action. You're going to basically activate the inspiratory. You're going to inhibit the expiratory. So you stimulate saying, hey, breathe in. You inhibit the breathing out part, which makes sense. So your inspiratory muscles contract. Expiratory muscles are relaxing, allowing for inspiration to occur. Deep breath in. You breathe forcibly in. You continue on. The DRG, dorsal respiratory group, and the inspiratory VRG now are inhibited. Remember, we've already taken our breath in. We need to breathe out. So you stimulate the expiratory VRG. So the ventral respiratory group, the expiratory ones, the ones that are breathing out, are activated. So your inspiratory muscles relax, expiratory muscles are contracting. That means it is now an active expiration. You're breathing out quickly. You're not just shallowly breathing out. It's not an at-rest breathing. You're actively forcing air out of your lungs. So that's for forced respirations here. So we were looking here. This is a blown-up picture of medulla and the pons. We're focusing just on these two down here, the VRG and the DRG. So the ventral respiratory group and the dorsal respiratory group. You'll notice they both send innervations to the muscles as well as diaphragm, internal costals, external costals there. So it's all those muscles. But what you'll notice we haven't discussed is a part up here in the pons yet. We've got to get to that later in another video. But what we're looking at so far is both the dorsal and ventral respiratory groups are playing roles in shallow, calm, quiet breathing, as well as forced inhalation and exhalation. So a little about how we're controlling the breathing from the nervous side as well as local.